Geometry, Chapter 2, Section 6. Special angles on parallel lines. So let's look at the idea of a transversal. A line intersecting two or more other lines in the plane is called a transversal. So in this diagram, this line is the transversal. And it creates three types of angle pairs: corresponding angles, alternate interior angles, and alternate exterior angles. So corresponding angles would be like those two angles. You have one angle that is on the outside. What do I mean by outside? It's not between the two lines. One angle that's on the inside is between the two lines, and both the angles are on the same side of the transversal. Notice they're on the same side, and they have one angle. Both angles are touching one of the yellow lines. So that is a corresponding angle. Alternate interior angles. Let me demonstrate another corresponding. Corresponding. And corresponding. Those are all the corresponding angles. Alternate interior angles would be these two angles. They're on alternating sides of the transversal, and they are both on the interior of the two lines. And they're both one on each line. So that's one alternate interior angle. The other alternate interior angle would be these two angles. Alternate exterior, same idea. Except now they're on the exterior of the two lines, alternating sides of the transversal. And so our other set of alternate exterior angles will be here and here. So let's identify on this diagram what each type is, and I'm going to abbreviate. So angle 1 and 7, angle 1 and 7, alternate exterior, angle 2 and 6, corresponding, angle 4, 8, corresponding, angle 3 and 5, alternate interior, angles 1 and 3, that's not one of the three we've introduced in this lesson, but we should know previously that those are vertical angles. Again, I'm abbreviating. Angle 2 and 5. We have no name for that. We have no name for that. Angles 1 and 5, corresponding. 6 and 4, alternate interior. Angles 4 and 3. Angles 4 and 3, again, it's not something from this lesson, but we know it from past. It's a linear pair. And then angles 4 and 5. It's also not a concept we've shown, but it does have a special name, unlike the angle 5 and 2. Angle 4 and 5 does have a special name. Some people will use same side interior. Some will use consecutive interior. So same side interior. Or consecutive interior. Now, when a transversal goes through parallel lines, there's a consistent result for each type of angle pair. Corresponding angles are congruent. Alternate interior angles are also congruent. And then alternate exterior angles are also congruent. That only happens when the lines are parallel. So I mentioned the idea of same-side interior or consecutive interior angles. And let's see what they actually are. Let's prove that they are supplementary. Let's prove that they are supplementary. Well, I'm going to go with the concept we know. Angle 1 plus angle 2 equals 180. I can say that because they're a linear pair. I know angle 2 is equal to angle 3. I can say that because they're alternate interior angles. And we know alternate interior angles are congruent. Now I can substitute 3 into the angle 2. Well, why can I do that? Because they're congruent. So now I have angle 1 plus angle 3 equals 180 by substitution. And so these angles are supplementary. Those angles are supplementary. Same side interior or consecutive interior are supplementary. Let's look at a little bit of algebra review. So here we go. We've got some parallel lines. Let's use some of that new knowledge we've gained in the idea of parallel lines. These angles are congruent because they are alternate interior angles. That means I can set them equal to each other and solve. So I get 5x plus 1 equals 4x plus 7. Subtract 4x, subtract 1, I get x equals 6. Now let's plug that in here. So 5 times 6 plus 1, 31. These two angles here are congruent because they are vertical angles. I also know these two angles are congruent because they're corresponding. Either way, I get 2y plus 15 equals 31. Subtract 15. 2y equals 16. Divide by 2. And y equals 8. Now, let's also look at some lines and determine, are they parallel? Now, we might just look at it and take a guess. Hey, they all look parallel. But there's an actual algebraic way we can determine whether they are parallel or not. Lines are parallel if they have the same slope. Remember, that is your rise over your run, your change in y over your change in x. So let's find the slope of each of these lines and determine which two are parallel. I go up 3 over 6. So the slope of m is 3 over 6. And I go up 4 over 7. Slope of p, I go up 2 over 4. Well, looks like none of my slopes ended up matching. So are any of them parallel? Yes, 2 of them are parallel because I can simplify my fractions. 3 over 6 is really 1/2. 2 over 4 is really 1/2. And so the lines that are parallel are M, and P. M and P, they have the same slope. Thus, they are parallel. And that is the end of this lesson.